In section 9.3, we have one more example of a special right triangle, and it's called a 30, 60, 90 right triangle. You can see here that all of our triangles have angles that are 30 degrees, 60 degrees, and 90 degrees. So let's see if we can come up with some shortcuts so we don't always have to use the Pythagorean theorem to figure this out. But in order to take a look at the rule, we are going to actually use the Pythagorean theorem. And just like in the last one, we are going to state our answer in simplified radical form. All right, so let's do the Pythagorean theorem here. We've got a squared plus 7 squared is equal to 14 squared. Right, because 14 is the hypotenuse, so we have to make sure it's on the other side of the equal sign where the c would go. So that would mean a squared plus 49 is equal to 196. So if we subtract 49 from both sides, that would leave us with a squared is equal to, 147. Taking the square roots, to get a by itself, we have a is equal to the square root of 147. Now let's put that in simplified square root form, simplified radical form. So the biggest perfect square that's a factor of 147 would be 49. 49 times 3. So the square root of 49 times the square root of 3 is the same thing as the square root of 147. And the square root of 49 is 7. So that no longer has a square root. So 7 times the square root of 3 is the answer for the leg across from the 60-degree angle. So the longer leg is 7 times the square root of 3. All right, let's go ahead and do that same idea in the second one here. So a squared plus 1 squared is equal to 2 squared. So we have a squared plus 1 is equal to 4. Again, do a little bit of algebra here, subtract from both sides, and now you have a squared is equal to 3. So a is the square root of 3. All right, square root both sides, a is the square root of 3. And that is in simplified radical form, so we don't have to do anything more with that. Let's do our third triangle here. A squared plus 2 squared is equal to 4 squared. So that means that a squared plus 4 is equal to 16. Subtract 4 from both sides. Change colors here. Subtract 4 from both sides, do the algebra, and we have a squared is equal to 12. So taking the square root of both sides, a is equal to the square root of 12. Simplified radical form. What's the biggest perfect square that's a factor of 12? 4 is the biggest perfect square that's a factor of 12. So we'll separate that out into the square root of 4 times the square root of 3, because 4 times 3 is 12. So we can separate those out into 2 square roots. And the square root of 4 is 2. So that gets that out from underneath the square roots. So the square root of 12 is the same thing as 2 times the square root of 3, and now it's in simplified radical form. Do you see the pattern here? How is that longer leg related to the shorter leg? Well, the shorter leg back here was 7. And what's our longer leg? 7 square root 3. What's our shorter leg here? 1. What's the longer leg? Well, square root of 3, that's really 1 times the square root of 3. What's the shorter leg here? It's 2. What's the longer leg? 2 times the square root of 3. That square root of 3 pops up in each one of these. And the length of the shorter leg is always what's in front of the square root of 3. And not only that, what's the relationship that we already saw between the shorter leg and the hypotenuse? 7, 14, 1 and 2, 2 and 4. Notice that the hypotenuse, hopefully you're seeing that, is exactly 2 times bigger than the shortest leg. 7 times 2 is 14. 1 times 2 is 2. 2 times 2 is 4. So that short leg is kind of the key to the other leg and the hypotenuse. So we don't have to use the Pythagorean theorem because this is a special rule. If the shorter leg has length x, then the longer leg is just going to be that x times the square root of 3. And the hypotenuse is exactly 2 times bigger, so 2x. So if we sketch out a 30, 60, 90 triangle here, and it's not to scale, so don't try measuring it with the protractor here, but let's say that this up here is our 60-degree angle and this is 30. What we're saying is that the short leg, which we know is across from the smallest angle, let's call that x. Our longer leg, which is always across from the 60-degree angle, is x times the square root of 3. And our hypotenuse, which of course is across from the right angle, is 2 times x. So that relationship will always be true. Let's see if we can do that in a couple examples here. So again, let's just sketch out a little 30, 60, 90 example here. So let's call this the 60, this is the 30. Now let's put in what we've got here. We know that the short leg is of length 4. And find the lengths of the long leg and the hypotenuse. All right, so we know that the short leg is x. We know that the longer leg is x times the square root of 3. And we know that the hypotenuse is 2x. Okay, well, we know x is 4. So that would mean that the longer leg, so the long leg, is x times the square root of 3. Well, that would be 4 times the square root of 3. Because x is 4, so 4 times the square root of 3. What's the hypotenuse? And I'm just going to abbreviate it here. The hypotenuse is 2 times x, in other words, 2 times the shortest leg. So 2 times 4, which is equal to 8. And we did have some units here, so let's put those on. So centimeters for 3 centimeters and 8 centimeters. Example number 2, if you have a 30, 60, 90 degree triangle and the longer leg is 12 square root 3, find the shorter leg and the hypotenuse. So once again, let's sketch this out. And you can do a better sketch than me sometimes when I'm up the active board. Things look a little different. All right. So let's sketch that out. 90 degrees, 60 degrees, 30 degrees. And the longer leg, again, is 12 square root 3. So that's across from the 60-degree angle. And we want to know the other 2 sides of the triangle. So remember the relationship. X times square root of 3 is the longer leg. X is the short leg. 2x is the hypotenuse. Well, let's look here. What is x? Well, x is the number in front of the square root of 3. So x right there is 12. So x is 12. That means that this side is 12. And if that is 12, then 2 times 12, 2 times x, it would be 2 times 12 is 24. So the short leg is equal to 12 centimeters, and the hypotenuse is equal to 24 centimeters. Okay, third example is the last combination. What if you know the hypotenuse is 15? Okay, then what? Okay, so one more time, let's just sketch out what we consider a 30, 60, 90 triangle, but we're just sketching it. And we're saying that the hypotenuse is 15 centimeters. Find the lengths of the other 2 legs. Once again, I'm just going to write my relationship. So we know this is 2x, we know this is x, and we know this is x times the square root of 3. All right, well, in this case, we know the 2x part is 15. So the shorter leg is just half of the hypotenuse, right? If 2x is equal to 15, that means that the x is actually equal to 7.5. Half of the hypotenuse. Okay, so short leg is 7.5 centimeters. And the longer leg is x times the square root of 3. So long leg, if it's x times the square root of 3, and we just found out that x is 7.5, then this must be 7.5 times the square root of 3. So longer leg is 7.5 times the square root of 3 centimeters. Okay, so once again, could you use the Pythagorean theorem? Well, in fact, in these, it's a little bit hard to use Pythagorean theorem because notice in every example in 1, 2, and 3, you're only given one side. So actually, Pythagorean theorem would be tough to do there because you have two unknowns. However, with the 30, 60, 90 rule, we know the relationship between all three sides, so we actually can use that to figure out the other two side lengths. Feel free to try the Pythagorean theorem now and double check that all the work is correct here. It should be.